18. The ultrasonic flowmeter. Ultrasonic flowmeter is a new type of flowmeter. Since the 1970s, with the rapid development of integrated circuit technology, it has been applied in practice. At present, it has been successfully used in the flow measurement of special occasions such as river flow and blood flow. In this lesson, we will learn the relevant knowledge of ultrasonic flowmeter. First, let's learn the principle of measurement. Ultrasonic waves propagate in a flowing fluid and carry information about the flow rate of the fluid. Therefore, the device that emits and receives ultrasonic waves can detect the flow velocity and flow rate of the fluid. The part of an ultrasonic flowmeter that emits and receives ultrasonic waves is called a transducer. Transmitting transducer produces ultrasonic wave, which passes through the flowing fluid in a certain way. Receiving transducer receives the returned ultrasonic wave, converts it into electrical signal, and finally gets the flow rate of the fluid through signal processing. According to the working principle, ultrasonic flow meters can be mainly divided into the following three types. First, the propagation time difference method. According to the time difference between two ultrasonic waves propagating in opposite directions is related to the flow velocity or volume flow rate of a river can be accurately measured. This is a relatively common method. Second, the acoustic deflection method. According to an ultrasonic wave, the offset generated by propagation perpendicular to the direction of fluid flow is related to the flow velocity to measure the flow velocity. Third, the Doppler method. Based on the Doppler effect of sound waves, that is, according to a sound wave, the frequency difference between the sound waves propagating along the direction of fluid flow and the backscattered sound waves is related to the flow rate to measure the flow rate. It is suitable for medical measurement, so it can be used medically to measure blood flow deep in human blood vessels. These methods have their own advantages and disadvantages and can be selected according to the measured fluid and measurement requirements in practical application. Propagation time difference method is a commonly used method, which can be divided into time difference method, phase difference method, and frequency difference method. The following takes the time difference method as an example to introduce the principle of ultrasonic flowmeter. The propagation velocity of ultrasonic wave in static fluid and flowing fluid is different. The propagation velocity of ultrasonic wave in static fluid is sound velocity c. Assuming that the flow velocity of fluid is v, the propagation direction of ultrasonic wave is the same as the flow velocity of fluid, and its propagation velocity is c plus v. When the two directions are opposite, the propagation velocity is c minus v. Using the measurement principle of the propagation time difference method, as shown in Figure 4-3, there are two groups of ultrasonic transmitters and receivers T1 or R1 and T2 or R2 respectively. And the propagation path of ultrasonic transmission and reception is L, then the ultrasonic propagation time from T1 to R1 is shown in the figure above, that is, T1 equals L over C plus V. In the opposite direction, that is, the propagation time of ultrasound from T2 to R2 is shown in the figure below, T2 equals L over C plus V. The time difference between the two beams of waves can be calculated. Since V much less than C in industry, the calculated formula can be simplified. It can be seen that when the sound speed is fixed, as long as the time difference between the forward and reverse propagation of ultrasonic waves is measured, the fluid flow velocity can be obtained. Next, we learn the main characteristics of ultrasonic flowmeters. 1. Ultrasonic flowmeter is a non-contact measuring instrument, which will not affect the flow field and has no pressure loss. 2. It has a wide range of application and is suitable for the flow measurement of various fluids and medium and low pressure gases in engineering. It performs well over certain flow measurement problems of fluids, including strong corrosion and radioactivity that are difficult to be measured by general flow meters, and can also make up for the shortcoming of electromagnetic flow meters unable to measure nonconductive fluids. The two-phase flow can also be measured by Doppler method. 3. The measurement accuracy is not affected by the conductivity, viscosity, density, corrosiveness, and composition of the fluid, nor is it limited by the diameter of the pipe. It is commonly used for measuring activities with pipe diameter of 5 to 20 centimeters and flow rate of 0.001 to 100 meters per second. 4. The propagation time difference method can only be used to measure clean liquid gases, while the Doppler method can only be used to measure liquids containing a certain amount of suspended particles and bubbles. 5. The Doppler method has low precision. In this lesson, we learned the measurement principle and main characteristics of ultrasonic flowmeter. There are still many applications of ultrasonic sensors, which are used in industry, communication, ranging, medical treatment, household appliances, and other aspects, which have been summarized and listed in the table. Today we only learned one of the types, which is ultrasonic flowmeter. For other types of ultrasonic sensors, you can consult relevant materials after class, understand the working principle and main characteristics, further consolidate and understand the working principle of ultrasonic sensors, and improve the learning effect. That's the end of this lesson. See you next time.